All right, hello everybody. Today we are going to be working on the lesson number 7 from the Addie Immunology unit. We've been talking about bacteria and how bacteria clone themselves approximately every 20 minutes, so their population doubles. We've been talking about antibiotics and how antibiotics and antiseptics kill bacteria. So today in investigation 1, we are going to try to answer the question, how many doses of an antibiotic would it take to eliminate 1 million bacteria if it was 90% effective? So what it's saying is I'm going to swallow a pill. That's my dose. That's my antibiotic dose. And if it kills 90% of the bacteria that are making me sick, how many doses do I actually have to swallow before I get rid of all the bacteria? And that's what we're going to, and this is just sort of imaginary, but we're going to try to figure it out. Okay, so if you're somebody who has the paper available to you, you're ready to go. You should have a pencil and you should be ready to go. If you're somebody who's doing the digital version, you might want to have a split screen. So you might want my video on the left side, and then the Cami, you want your worksheet open using Cami, and then you want Cami open on the other side so that you can write while I'm talking, and you're going to want to write really fast. I suggest using your stylus and writing rather than trying to use the text boxes, but you can use the text boxes if your handwriting is really messy or something like that. Okay, let's go ahead and get started. So the first thing that we want to do in this data table is fill in the number of doses. Excuse me. So for example, I started it for you, a 1 here, a 2 there. Should go, I think, all the way down to the number 9, if I remember correctly. So go ahead and write 1 through, is it 9? Whatever. Fill in each of those boxes. Okay, and then right here, it says how many bacteria are there before the dose. So we're going to start with 1 million bacteria. So you write 1 million bacteria here. And then we want to know how many of the bacteria are killed. And that's a little bit complicated. So I'm going to switch screens. You're still going to be writing on this screen or on your paper, but I've got a PowerPoint presentation that I'm going to show. Oh, you know what? I think my image goes away when I show the presentation. I hope you can handle not seeing me in the presentation. All right, I'm gone, but whatever, it'll still work. So let's get this going. Give my computer just a second to load it. Okay, so you've written 1 through 9 under the doses. So now we have to figure out how long or how many bacteria does it kill every time you swallow the antibiotic. So to calculate that, you do 1 million times 0.9. That's 90%. 0.9 is 90%. And that tells you how many bacteria you killed. But now we need to figure out how many bacteria are still left alive. So the first, in this box right here, you're just going to write 1 million. In the box next to it, all you have to write is 900,000. But what do you write in the last column? What do you write there? So that's where you subtract 1 million minus 900,000 gives you 100,000 bacteria. So even though it killed 90% of the bacteria, a million's a pretty big number. So you still have 100,000 bacteria left behind. Okay, so now let's go to dose number 2. If we have dose number 2 and it kills 90% of the bacteria, how many bacteria are still going to be alive? And you can just write these numbers down. You're going to have to write fairly quickly because I want you to be able to get done quickly. So 100,000, and then it killed 90,000 of them, so that means there were 10,000 left. After the third dose, there's 10,000. It kills 90%, so there's 9,000 left. There's 9,000 that are killed. And so at the very end, there's 1,000 that are still alive. So we take the next antibiotic dose. You start with 1,000, you kill 90% of them, which means you kill 900. And so you're left with 100 bacteria. Now remember, that's a big deal because 100 bacteria, if they double every 20 minutes, that starts increasing incredibly fast. We say that's exponential growth. So that can be a problem if you have 100 bacteria left. All right, by dose 5, if you started with 100, you killed 90% of them, then there'd be 90 that you killed, and that means you have 10 still left. By dose number 6, you have 1 bacteria left, and by dose number 7, close enough, we say that you have 0 bacteria left after the dose. So it would take approximately 7 doses at 90% effectiveness. Now, this is too simple because we weren't trying to control for time here. We weren't saying what happens. You swallow the dose, but you don't get to take all the doses one after the next. You have to wait some hours. And during that time, the bacteria that are still alive, they're going to be reproducing. And so we're going to do some somewhat more complicated math. So now let's take a look at investigation number 2. How would both reproduction and repeated doses of antibiotics affect the size of the bacteria population? So this time we're going to take into account that those bacteria are still dividing, the ones that are alive. So it says, let's figure this out by building a new mathematical model. That was a model that we already built, but it was pretty simple. So we're making a more complicated model now to predict what would happen to the population hourly if we start out with an initial infection of 1 million bacteria. Same idea. We took our first dose of antibiotic immediately. So right at hour 0, we're going to swallow the antibiotic. And the antibiotic was much more effective this time. So instead of 90% effective, it was 99.99% effective. So that means that we're going to be multiplying the number of bacteria times 0.9999 each time. Any surviving bacteria continue to double every 20 minutes, and we took another dose every 4 hours. So that's pretty typical that you would take an antibiotic every 4 hours. Some of them it's every 8 hours. It depends on the antibiotic. Okay, let's see what would happen. So this is on page 2 now of your packet. And so at time 0, there are 1 million bacteria in your body, and it says antibiotic dose given, yes. And so how many are alive after you take your antibiotic? Well, we wrote down the number 100, and you should write it on your sheet. So how do you get 100? So it's 1 million minus the number of bacteria that are killed. Well, how do you know how many bacteria are killed? Well, we did that in our first model. We've already done that before. So the way you figure out what's in parentheses right here, the bacteria killed, it's 1 million times the 99.99% effectiveness, and you use the decimal version of that. So it's 0.9999 times a million. So the whole equation is 1 million minus what's in parentheses, 0.999 times a million. So what that means is you kill 999,900 bacteria with that first dose, but 100 bacteria are still there. Well, who cares? 100 bacteria, so what? Well, bacteria double every 20 minutes. So now we need to know what to write next to time in hours where it's hour 1. How many bacteria will there be? Well, after 20 minutes, they'll double, so that's 200 bacteria. After 40 minutes, they'll double again, that's 400 bacteria. And after 60 minutes, 1 hour, they'll double again, and so that is 800 bacteria. That's a lot of bacteria. So you write down 800 in that spot. So then for the next hour, the same thing happens. They double. So that's 1,600, then they double again, that's 3,200, then they double again, and that's 6,400 bacteria. So an hour later, you're going to have 6,400 bacteria. So I'm going to have you keep writing it down. So hour 3, you have 51,000 bacteria, 51,200. Get that number written down. And then by hour 4, you're back up to 500,000 bacteria, 409,600. Write it down, which is really crazy. So you took an antibiotic and you killed 99.99% of them, but 4 hours later, you have almost half of them back again because they grow so fast. So I really want you to think about what happens if you're taking an antibiotic and you forget to take a dose. It can really be a problem. Your body is going to start getting sick again, and it makes it harder to fight off the infection. Okay, so at hour 4, we do take the antibiotic again. So we're going to need to do that 409,000 minus, and then we're going to kill 99% of them again, 99.99% of them. So you multiply that out, and what you're left with is 41 bacteria. So it shows that we're going down. The first time we were left with 100 bacteria. The second time we're left with only 41 bacteria. Now they need to double and double and double. So they're going to double 3 times during the course of the hour. So if you remember, that was times 2, times 2, times 2. So it'd be nice if there was a formula for that. And there is a formula for that. The formula is whatever that number is, 41 times 2 to the third, 2 times 2 times 2, which is 8. So just every hour that you're not swallowing the antibiotic, you're going to multiply the number of bacteria by 8. So that gives us an answer. So for this next one, it's 41 times 8 is 328. So by hour 5, there's 328 bacteria. Now we're going to multiply it by 8 again, and we're going to get I'm going to let you go ahead and fill it in. So there we go, 2,624 bacteria by hour 6. And then we're going to multiply it by 8 again, and we're going to get 20,992. I hope you're keeping up with me. You got to write all these numbers in. Okay, by hour 8, that's where we take our antibiotic again. So you have 167,000. It's getting better. 936. So 167,936. Now you're going to kill 99% of them with the antibiotic. So how many are actually left? And I'm going to let you go ahead and fill in the data here. So we don't need to do all of the math, but you're getting the idea of what's going on. So if you want, I can read them to you. So at hour 8, when you swallow the antibiotic, you should have 16.8 bacteria. Hour 9, you should have 134. Hour 10, 1,074. Hour 11, 8,590. Hour 12 is where you're going to take the antibiotic again. So that's 68,719. And once you've swallowed the antibiotic, you have between 6 and 7 bacteria left. So 6.9, there's no such thing as 6.9 bacteria, but we're going to let you go ahead and have some decimals here, and that's close enough. Okay, so then the 6.9 bacteria need to double every 20 minutes. So we're going to multiply it by 8. So for hour 13, we'll have 55. Hour 14, we'll have 440. Hour 15, we'll have 3,518. And by hour 16, we'll have 28,147. That's when you take the antibiotic again and you kill 99% of them. So you're left with between 2 and 3 bacteria in your body. So we say 2.8 for that one. Okay, multiply that by 8 because they're doubling every 20 minutes. So for hour 17, you have 23 bacteria. Hour 18, you have 180. And hour 19, you have 1,441 bacteria. In hour 20, you're going to take the antibiotic again. So you have 11,529 bacteria to start with. You swallow the antibiotic and kill 99.99% of them, and you're left between 1 and 2 bacteria. So we're getting super close to wiping them out. So then they double and double every 20 minutes. So hour 21 is 9. Hour 22 is 74. Hour 23 is 590. And hour 24, you have 4,722. You swallow your antibiotic, which kills 99.99% of them, and you're going to have somewhere between 0 and 1 bacteria. So then on your worksheet, there's a question that says, did you wipe out all of the bacteria in our imaginary scenario after 24 hours? And I'm okay. Let's say for the answer, you could say we'll have between 0 and 1 bacteria left after 24 hours. So for that question, you can say we have between 0 and 1 bacteria left after 24 hours. You have between 0 and 1 bacteria left after 24 hours. Excuse me. Okay. So now we need to do a graph. I don't know if you remember that we graphed how the population increases when it's increasing exponentially. We did that on a previous assignment. And we showed that there were very, very, very few bacteria for many hours. But because they were increasing exponentially, the graph went really, really fast up to the right. It's a curve, and it goes up super steep up on the far right side. Okay, this graph is similar, but it's a lot more complicated. So the first thing we need to do is on the side, we're going to plot how many bacteria are still alive. So those are the numbers on the left. And then down along the bottom, we have the number of hours. And on your worksheet, it underlined every time you took a dose. So at hour 0, you took a dose. At hour 4, you took a dose. At hour 8, you took a dose. That's what the underlining means. And now you need to just plot the points. And so I'm showing you sort of roughly what those points look like so that you can get started. So you're going to see at hour 0, you had 1 million bacteria. And by hour 1, you hardly had any bacteria at all. And then by hour 4, you're back up really high again, and then it drops down significantly. So let me just show you. I'm only going to show it to you for a moment, and then you need to finish the rest of your graph. So I'm going to show it to you for a second so you see what the shape of your graph is supposed to look like. Ready? Watch this. This is what your graph is supposed to look like. Now I made it go away. You need to finish your graph. You need to plot the rest of your points and connect the dots so that it looks like the graph that I just showed you. Okay, and then we need to answer the last couple questions at the end. So I'm going to go ahead and scroll down to the very end. Number 6 says, write an explanation that tells how the mathematical model you co-constructed in class, well, we did it on a video, but whatever, helps us understand why it is necessary to take all of the prescribed doses of antibiotics, even when we are already feeling better, in advance of finishing them. So remember, the first time you took that antibiotic, it killed 99.99% of the bacteria. You only had 100 bacteria in you, so you feel way better. Why did you need to take the next antibiotic dose? Okay, so that's what we want to answer there. So you would want to say something, you choose your own words, but you want to say something to the effect of, because the bacteria double every 20 minutes, if we leave behind even one bacteria, the population will explode within a matter of hours. So you need to write something to that effect. I'll say it again. Because bacteria double every 20 minutes, if we leave behind even one bacteria, the population will explode within a number of hours. Okay, pause this video if you need to write that down. I'm going to move on to the last question that we have today. And you don't need to answer question number 8. If it's on your worksheet or packet or whatever, you don't need to answer that question. Okay, number 7 says, how is what we discovered through this lesson relevant for explaining what might have happened to that little girl that got sick, whose name was Addie? So I want you to remember that she kept getting better. They would give her antibiotics and she would feel better for a while, and then she would start getting sick again. She would feel better for a while on a new antibiotic, and then she would get sick again. So I want you to imagine what's going on in this graph, how the graph drops down, but then it comes back up again, and then it drops down, and then it comes back up again. That's the pattern that we're seeing with Addie. So I think it's safe to assume that what's going on with Addie is that the antibiotic initially kills lots of bacteria, but not all of them. And so they start dividing and they come back and she feels sick again. So they put her on a new antibiotic. It kills lots of the bacteria, but not all of them. And so they start dividing and they come back and she gets sick again. So how is what we discovered through this lesson relevant for explaining what might have happened in Addie? You need to figure out how to word that every time she's taking antibiotics, they're killing lots of her bacteria, but there are some resistant ones that aren't dying, and they are reproducing and reproducing and reproducing and making her sick again. So every time they give an antibiotic, she feels better. But then those strong bacteria, the resistant bacteria, they come back and make her feel sick again. Okay, replay that if you need to, but you need to write that for number 7. That's it, everybody. We're done for today. Let me know if you have any questions. If you did the paper copy, then you just turn it in to me. So just give it to me and I will give you the points for it. If you did the digital copy, you need to email it to me so that I can give you credit for it. That's it, everybody. Have a great rest of your day.